Welcome to 2.2 Characteristics of Quadratic Functions, Part 2. We're going to start with graphing quadratic functions using x-intercepts. When the graph of quadratic function has at least one x-intercept, the function can be written in intercept form. F of x equals a times x minus p times x minus q, where a cannot be equal to 0. Because when you plug in p into the f function, it gives you 0, or if you plug in q into the equation, it gives you 0. These two are called x-intercepts. The axis of symmetry lies right smack dab between the two. So if this is p and this is q, your axis of symmetry lies right smack dab in the middle. And that's why you got p plus q over 2 is your axis of symmetry. Same thing with the other parabolas. If a is greater than 0 or greater than 1, it's wider, or it's narrower. If it's between 0 and 1, it's wider. It's a vertical shrink. If it's negative, it also opens down. If it's positive, it opens up. Same idea. It's the same a value. Let's look at example 4. Graphing a quadratic function in intercept form. So it's already in intercept form, so that's kind of nice. And we need to break this apart. So we're going to take x plus 3 and set it equal to 0, and x minus 1 and set it equal to 0. These are going to be your two x-intercepts, and you solve. So x equals negative 3 and x equals 1. So I get the point negative 3, 0, and I get the point 1, 0. Graph those 2 points. Those are your x-intercepts. The axis of symmetry lies right smack dab between the two. So the axis of symmetry, if you take negative 3 and 1 and then divide by 2, you get negative 2 over 2, or negative 1. So x equals negative 1 is your axis of symmetry. And you see that axis is right between the two x-intercepts. We know the vertex lies on the axis of symmetry, so we plug that back in. Plug in negative 1. And simplify. Negative 1 plus 3 is 2. Negative 1 minus 1 is negative 2. Negative 2 times 2 is a negative 4. Negative 4 times negative 2 is 8. So I get the point. Negative 1, 8 is your vertex. We can sketch it just from these points. So nice smooth curve. Nice smooth curve. And there's your parabola. Notice how it does open down and our a value is negative, so that kind of verifies that we graphed this correctly. All right, let's look at solving real life problems. The parabola shows the path of your first golf shot, where x is the horizontal distance in yards and y is the corresponding height in yards. The path of your second shot can be modeled by the function f of x equals negative 0.02x times x minus 80. Which shot travels farther before hitting the ground? Which travels higher? Okay, so farther means our x intercepts. And yes, this equation is not written quite how we know intercept form is, because we just have an x. Well, that's x minus 0, okay? You can write it that way if you wish, but that means one of your x-intercepts are 0 and the other one is 80. So we get x-intercept of 0, 0 and 0, 80. And the vertex here, so this is your any label. So let's look at our vertex. Our vertex lies right smack dab in the middle between these 2 points. So we're going to add 0 and 80 and divide by 2. That's our x value. That's our, well, axis of symmetry. So that is 80 over 2, which is 40. Plug 40 back into our function. I didn't quite plug that in correctly. This needs to be 40. We plug it into our calculator and find the solution. And this gives us 32. So our vertex is 40, 32. So let's answer our question. Which shot travels farther before hitting the ground? Okay, so if we look at our graph that's provided here, this golfer hit the ground at 100 yards. Our golfer hit the ground at 80 yards. So definitely the first shot went longer. So let's write that. So the first shot, the first golf shot, traveled further. And which shot, which traveled higher? So the height is the y value. So this is 25. This one, the height, is 32. So the second shot actually traveled higher. So the second shot, so the second golf shot traveled higher. And that is lesson 2.2.